about?
Hey there, Brian. I'm actually thinking about 3D printing a part.
3D printing, huh? I've heard of that, but what is it exactly?
So actually it should be called additive manufacturing. It's kind of the opposite of normal manufacturing techniques. Have you heard of a mill or a lathe?
Yeah, I've heard of a mill. That's where you drill holes and stuff. And then a lathe is where it spins and you cut away material.
Yeah.
Oh, so those would be subtractive manufacturing because
Yes.
you cut away material.
Yes.
And then 3D printing is additive manufacturing
Correct.
because you add material.
Yes, that is exactly
That makes a lot
correct.
of sense.
Yeah, so additive manufacturing, you're correct. It adds stuff layer by layer. I think it's the future of regular manufacturing technology.
So what kind of parts can you produce with additive manufacturing?
Well, really, you can create anything. Right now, I'm trying to create a project for JMS, but you can create anything from, say, Christmas ornaments to biomechanics materials.
Wow, and you can do that here at KU?
That is correct.
Really? And what kind of 3D printers does the mechanical engineering department have?
So here at KU, we only have 3 printers. We have the Uprint, the Object, and the Mojo.
That's pretty neat.
This is the Stratasys Mojo. It uses ABS Plus material, and this is the cheapest printer and the lowest resolution we have here at KU Mechanical Engineering. And the biggest you can print on this baby is 5 by 5 by 5 inches. And this right here is a Stratasys Uprint SE Plus. It has a build volume of 8 by 8 by 6 inches. It uses ABS Plus material, and it has a slightly bigger build volume, prints quicker, but it's a little bit more expensive. And this right here is the Object 30 Prime. It has a build volume of 9.5 by 9.5 by 7 3/4 inches. It has ultra fine detail, very high resolution, and slightly higher cost. It uses 15 printing materials, and it has minimal post-processing. How neat is that?
Wow, there sure are a lot of printers here at KU, but how exactly do you go about the 3D printing process?
Well, it all starts with an idea. And then you transform that idea into AutoCAD or SolidWorks. And then that goes to an STL file, and then it gets into the printer. But first, you need to make sure that the printer has printing material. It goes right here. Printing material. And then you wait. And then you really do have to account for the waiting time.
So what exactly is an STL file?
Hi, I did not see you there. STL stands for Standard Tessellation Language. An STL file is the same thing as an AutoCAD file, but it's all cut up in little layers so your 3D printer can read it.
All of the 3D printers here at KU take some sort of pre-processing or post-processing. Pre-processing are steps you need to take in order to prepare the printer to print, and post-processing are steps you need to take in order to polish up your final product. Some common pre-processing steps here at KU are sticking these little trays into the 3D printer. They act kind of like cookie sheets. Just like you don't want cookie residue stuck on the bottom of your oven, you don't want support material residue stuck on the bottom of your 3D printer. Another thing to take into account when you're setting up your part orientation in the print wizard, is just how it's oriented. If you have a large overhang, you may want to turn that part 90 degrees so that it uses less support material and takes less time to print. Another thing to take into account is whether you're using sparse or dense fill. Sparse fill takes a lot less time and makes a slightly less stable part, and dense fill takes a lot more time and uses a lot more material, but makes a lot more solid parts. The final thing you need to take into account is post-processing. Post-processing here at KU is basically just removing support material from your final part. So for the object, sometimes you just have to cut it off with a Dremel. And for the Uprint and the Mojo, you have to stick it in a bath and let it soak and dissolve off. And that's about it for pre-processing and post-processing.
After all this information, you might think you're an expert at additive manufacturing. However, you need to determine whether it is worth using the long production times of our 3D printers. To help you with this, we have attached a PDF called Design for Additive Manufacturing, created by Purdue Engineering. The purpose of this sheet is to walk you through your CAD drawing to see if it meets various requirements. Going through this sheet will help you to prevent mishaps during and after production. The first category is complexity. Many times it can be a waste of time to 3D print a piece that has simplistic geometry. For example, if you're trying to print a cube, it may be useful to use a mill instead. The next category is functionality. 3D printed parts need to be used in a function that has it moving as little as possible. The reason is that the materials used in 3D printers cannot handle a large amount of stress, and using these parts in fast-moving functioning jobs only risks the chance of part failure. The next category is material removal. You should note that you do not want thin structures or cavities in the object to be exposed to support material. This is due to risk of breakage during post-processing. A lot of times this can be prevented by orienting your part in a 3D printer correctly. The category of unsupported features is to remind the user that orientation is key to ensure successful 3D printed parts. The category of thin features illustrates that 3D printers have a minimum thickness to create quality parts. The next category, stress concentration, shows the edges of the part should be more rounded to prevent breakage. Tolerance and geometric exactness are categories that have to do with the quality of the created CAD drawing. Since this video is not about CAD, I won't go into much detail. Once you have gone through all of the categories, add up your score using the column on the right side. Using the legend at the bottom, you can determine if your part is ready to start printing or you need to go redesign your part. Have fun 3D printing.
But remember,
Safety first!
but remember,
Safety first!